Hello, this is Mr. Stansbury. I'm going to take you through the notes on interval notation. At the end of this, you should be able to say I can use interval notation to describe various number sets, and I can decipher interval notation to represent a number set graphically. Okay, so first off, let's look and see what interval notation is. Interval notation is a way to describe a set of elements. Okay, so these brackets here, we're going to start off with the set of all. This is integers. The z is the integers. The element x is going to be an element of integers such that x is greater than or equal to -5 but less than or equal to 10. Okay, or another way we can say that is x lies between -5 and 10 inclusive. Okay, so again, another way to read this, this reads the set of all integers such that x lies between -5 and 10 inclusive, because it's got the underlines. Okay. Let's take a look at an example. Here's set A, and it says here, write down the meaning of interval notation, of the interval notation. Okay, so this is going to be the set of all integers where x is greater than -1 but less than 5. Okay, okay, so we would just write it like that. Okay. List the elements of set A, so all of our integers from -1 to 5, but not including -1 or 5. So if we're going to list those elements, that would be, with first one we'd start with would be 0, 1, 2, 3, and 4, but not 5 because it's got to be less than 5. Okay, and then part C says find n of A, so that's the number of elements in set A. 1, 2, 3, 4, 5. There are 5 elements in set A. Okay. All right, example, represent on a number line. So we have x is the natural numbers where x is less than 4. So if you'll remember, natural numbers start at 0 is the lowest natural number we have, and then we could do 1, 2, 3, but we can't include 4 because it's got to be less than 4. So it's just going to be these 4 spots, okay, because it's only the natural numbers, it's not all the real numbers. Okay. For B, x is all the real numbers such that x is between -1 and 3 and including -1, right? So we could do -1 at the bottom here, +3 at the top, and then it includes -1, but it does not include 3. So we'd leave that as an open circle, and then we just draw ourselves a little line between those two. And any point along this line, or at that point, but not this point, would be would fulfill this interval notation. Okay. C, x is an element of the real numbers such that x is greater than 2. So let's put 2 on there. Not equal to, just greater than, and we're going to put, it's everything that's greater than, so we'll put a line going to the right and an arrow. All right. Okay. Let's look at another example here. Write these in interval notation. Okay, so since it's got the solid line, we know that means the real numbers. So we're going to go the set of numbers. X is an element of the real numbers such that, and it starts, let's see, it starts at 3, and it doesn't have an ending. So x is going to be greater than, and it's not equal to 3. Okay, you could have also written this as x is greater than 3. Either one of those would have worked. Okay. For B, again, we've got all real numbers here. So x is an element of the real numbers such that it starts at -2 and then it ends at 6. Right? It includes -2, greater than or equal to -2, but it is less than but not equal to because it's not filled in for 6. Okay. On C, we've got the dots here, so that means either the natural numbers or the integers. Since this one here starts at -1 and includes -1, it's got to be the integers because natural numbers start at 0. So we're going to do x. It's going to be an element of the integers such that we're going from -1 to 4, and then x has to be less than or equal to -4 or greater than or equal to -1. Okay. Now, we could have done the same thing with this here and said that it started at, say, -2 and ended at 5 so long as we didn't put the equals to, because x is greater than -2. The first integer that's greater than -2 is -1. And then the last integer that is less than 5 is 4. All right? Okay, let's take a look at a couple more examples. But first, let's take a little comedy break here.
Whenever there's a best of 7 series, because then I get to hear my favorite sports reporter question. Would you consider this a must-win game? You know, they always feel like they have to say yes. Yeah, we want to win it. It's very important, you know. Got our uniforms on anyway, might as well try. But it's not always the right answer, man. It's a math question. I wish I would answer that question honestly. It's a best of 7. You're down 1 game to nothing. Would you consider this a must-win game? No. No, we can lose tonight. We can lose tomorrow night, too. We don't want to, but that wasn't your question. You asked if it was a must-win game, and if you'd ever taken a rudimentary math class, you'd already know the magic number's 3. When you're down 3, then you must win them or you're out.
Okay, just a little fun from Brian Regan there. Okay, example 4. U with the little, looks like a little horseshoe type thing there. That's our universal set. Okay, so that means the universal set are the only numbers that we're worried about at all throughout this entire problem. We don't know any other numbers. The only numbers we care about are in the universal set. Okay, and then it gives us set A, set B, and then it's going to ask us to list all the elements of these things here. Now, it doesn't say to list the elements of the universal set, but it's going to help us out. So I'm going to just go ahead and list the universal set. So let's do that here. Universal set is... Now, it's the integers from -2 to 6, and it includes -2 but not 6. So we're going to go -2, -1, 0, 1, 2, 3, 4, and 5, but not 6 because it has to be less than 6. Okay, so these are the only numbers that are going to show up anywhere in the rest of this problem, because these are the only numbers that we are concerned about for this problem. All right, so for set A, let's see, it says list all the elements of set A. So from -2, the integers from -2 to +2. Okay, so again, -2 is in there, and we can just list all those off. -2, -1, 0, 1, and 2. Those are all the all the elements of set A. Integers from -2 to 2. Oh wait, but look, this is x is greater than -2, so it cannot include -2, so it's just -1, 0, 1, and 2. Okay. For part B, we're going to list set B. So set B is this one here. Elements of the integers where x is greater than or equal to 0, but less than or equal to 4. So that's basically from 0 to 4, and that includes all these. So we're okay. 0, 1, 2, 3, and 4. Okay, so that's set B. Okay, next one is A prime. So A prime, the prime of the set, is basically everything that's in the universal set that's not in set A would be A prime. So if we take set A and A prime and we take the union of that, we're always going to get the universal set. Okay, so if we add these two together, we'll always get the universal set. So basically, we got to figure out, okay, we've already got -1, 0, 1, and 2. So we already have these right here, -1, 0, 1, and 2. Which parts do we not have? Oh, we don't have -2, 3, 4, or 5. So -2, 3, 4, and 5 would be the A prime. Okay, another way to possibly look at this to maybe make it a little bit easier is if we just rewrite our universal set. We got -2, -1, 0, 1, 2, 3, 4, and 5. What we can do with this is say, okay, I'm just going to cross all these off, and then whatever's left is going to be A prime. So we would cross off -1, 0, 1, and 2. And what's left over? -2, 3, 4, and 5. -2, 3, 4, and 5. Okay? For D, we're going to do B prime. So we're going to do the same idea. So let's get rid of those, and we'll reuse this to figure out what B prime is. All right. So if B is 0 through 4, so we would cross off 0, 1, 2, 3, and 4. What's left over? -2, -1, 0, 1. Oh, dirt. I'm reading off ones that are already in there. Sorry. -2, -1. All those are already in there. And then 5 is the last one. Okay? All right. On to E. Okay. A union B is going to be everything that's in A and everything that's also in B, an either or, right? That's the U is the either or. Okay, so we've got -1, 0, 1, and 2 all from set A, and then the 0, 1, and 2 are already accounted for. Now we got to put also in 3 and 4. So that would be A union B. All right. A intersect B is what they have in common, right? So what do A and B both have? So let's see, with this, the A and B both have 0, 1, and 2. So they have those 3 in common. So it doesn't mess us up for later. So we got 0, 1, and 2. That's what they have in common. Now we want to figure out what A prime intersect B prime is. So we have A prime and we have B prime, and then this intersection again means what do they have in common? So they have -2 and 5 in common. So that would be the answer for this one, -2 and 5. All right, and then last one would be A prime union B prime. So what do these two things have? Like it's the combination of those. So let's see, we got -2, -1, if we're listing them in order, which you don't have to, but it just makes it a little cleaner. -2, -1, 3, 4, and 5. So that means if we look for A union B, -2, -1, 3, 4, or 5 will be at least in one of those two. And then we know -2 and 5 is going to be in both of those two. Okay? All right, that's all we have for interval notation. If you have any further questions, please feel free to ask in class. Thanks.